By the end of this video, you will have an understanding of what object pooling is, how and why we use it, and how to implement it using Unity, C and C#. For the best tips and tricks on game programming and game development, subscribe to my channel and hit that bell icon to get notified when I upload new videos every Monday. If you're already a subscriber, thank you. It really means the world to me. Hi, my name is George Wulfers and I'm a professional game developer. Let me guide you on your game development journey to find out how you can get more free learning resources. Be sure to watch this video to the end. Step number 1. What is object pooling? Object pool is a creational design pattern in software development where it holds a set of objects that have been pre-initialized and ready to be used instead of allocating and destroying objects. Step number 2. How and where do we use this? We use it in areas where it would be expensive to create and allocate memory for use of this object and then delete it. Instead, at runtime, we have a set number of objects that have been initialized and recycled throughout the lifetime of the game. This will reduce overhead on the CPU to allocate and delete memory constantly. We use this pattern in several places. One common place would be when shooting any sort of bullet or projectile. Since we will use them often, instead of creating them every time and deleting them shortly thereafter, we can just have a pool of bullets ready to be recycled without having a major cost in memory allocation every second. As software developers, we need to make sure that our applications run smoothly and as fast as possible, especially if we make real-time applications such as video games. Alright, I hope this is making sense. Let me know in the comments below if there's anything you are struggling with. Step number 3, implementation.
All right, so let's open up our project and let's go into the scripts folder, foundations folder, right click, and let's create a new C# script. We're going to call it pool data. Let's open it up. The first thing that we need is our namespace as always. We're going to create it inside of the foundations and we're just going to name it object pooling. So this is going to let the compiler know that we want to create a menu name inside of the create asset menu. Whenever we create a menu, we're going to name the file new pool data, and the menu name, the actual name, is going to be scriptable objects pool data, and it's going to be the first one. The pool data is going to be inherited from scriptable object. If you guys don't know what a scriptable object is, I'm going to be putting the link down below to Unity's documentation, but essentially what it is a container that you can use to save large amounts of data. This data, or this class, is independent of any class instances. And one of the main uses for a scriptable object is to reduce the project's memory usage by avoiding copies of values. So this is accessed via references and not copies. So like I said, if you want to read more on it, you can go to the link below and look at it there. But essentially what I've used this for, and this is this is a recent addition into Unity. It's probably like within a few years since this one has been added, but I really love this class. Pretty much what I've used it for in the past projects have been for configuration files where you have, let's say you're working on a tool or you're working on a level and you want each level to have its own configuration file that you tell it what assets it needs to load and maybe what sounds it needs to play based on where you are, what enemies it needs to load based on some criteria. The cool thing about the scriptable objects is that it's not just data that you can hold in here. You can also have functions or functionality um, that allow you to either parse through some of this data or do something useful with it. Another cool thing about it is that previously, when you've tried to tweak values within a game object, you often, when playing in the editor, once you were done playing, if you didn't write those values down, they were gone. You didn't have those values at all anymore. The cool thing about this is that you can actually write those values into a file like this, or actually if your object is reading from this file and you tweak it, um, you can it actually saves regardless of whether you're playing in play mode or not. So that's another cool feature. What we're going to be using it for in this tutorial or in this series is to hold different, because we want to make this object pool versatile, and have we don't want to have the issue of remaking something, or we want it to be flexible enough, and we're going to be making several pool data assets that are going to have different types of they're going to have different prefabs that you can load and maybe different number to spawn variable. Married leg instead of 5 is going to be 10 or something like that based on what it is. And we may add more stuff into this, but this is pretty much going to be the data that tells the system what it needs to spawn. All right, so let's go ahead and right click again and create another C# script. Let's call it object pool, and let's open that up. We're going to have our namespace as usual, and it's going to be inherited from a mono behavior. The reason it's not going to be a mono singleton is because we may want um, different object pools with different data. We could make it a singleton and then we'll just have a list of pools, but that can get a little bit trickier when you're requesting, because then you have to specify now the type of object you want. So we have a list here of game objects. That's going to be the available list or pool where the system is going to draw from, I guess. In the start function, we're going to first check to see if the pool data has been filled out properly. If it doesn't, then we're going to tell someone that they made an error and we're just going to return. We're not going to run this at all. And if it succeeds, then we're just going to go from 0 to number to spawn. So from 0 to 4, if it's 5, and we're going to instantiate or create every game object based on the prefab that we selected in our pool data, and we're going to add that into um, the available list, and we'll see how we do that in a bit. The spawn object takes in the position and the rotation that you want the object to spawn in, and it's going to return a game object. We tell the system that we want to request a game object, so it can return null or an empty game object. If it doesn't return a null object, then we can assign it the proper position and rotation that we want or that they have requested, and we set it to be active. When an object is active, it allows it to be rendered, and if it has any scripts, it allows those scripts to get triggered or executed, and then we're going to return that object. And then for the request object, we're going to return a game object, and it doesn't take anything. We're first going to set our object to be null because we don't have any. And then we're going to check to see if the available pool, if the size of that pool, if it's greater than 0, that means we do have something. If we do have something, we're going to get the very first index, and we're going to remove it from that pool, and then we're going to return it. And that's pretty much it. And this one has to be public, and it's going to be called return object, and all it needs is to take in the object that it returned. And we're going to make sure that it doesn't contain it inside of the pool when we're trying to return it. The reason for this is because we don't want two different objects to be referencing the same object, because then they're going to be fighting for control, and that's not good. And then we're going to reset the position and the rotation back to 0, and we're going to set it to false, so we don't want it to render or update at all. And then we're just going to add it back into the pool of available objects. And that's pretty much it.
Step number 4, testing.
Okay, so let's go back to Unity now, and let's create a demo and test it out. So the first thing we're going to do is we're just going to grab, we're going to create a C# script. We're going to call it spawner demo. And then, okay, so let's just click Control Save, and we're going to go into our scenes. Actually, not the scenes. We're going to go into Scripts, Foundations, Demo, and we're going to call it Object Pool Demo. And let's open up the spawner demo script. Okay, so we have our simple demo spawner. We're going to need a reference to our object pool here. And we are going to, this is our timer. We're going to have two timers. We're going to have a spawn timer and a removal timer. This is the delay in seconds, and this is the delay in seconds for this one. And this is the actual timer here. I'll show you how it works later on. We're going to have another list that we're going to keep track of all of the objects that we requested so that we can return it once something happens. And in the start function, actually not the start function, that'll be in the update. So we're going to add delta time into our spawn timer. Delta time, if we see here, it's the completion time in seconds since the last frame. So we're just going to be accumulating that. And if it reaches or if it's greater than the delay in seconds for that spawn timer, we're going to just set it back to 0, and we're going to ask the pool, the object pool, to give us an object and to set this position and rotation. And if it does give us something, we're just going to add it to the pool. And then we're going to go through each one of these objects, and we're just going to change their position so that we can see it working. And then we're going to be doing the same thing with our removal timer, just incrementing it until it reaches a certain threshold. Then we're going to set it to 0 so it can do it again. And in this case, if we're going to check to see if there's any objects inside of our list here. And if there are, we're just going to get the first one, and we are going to tell the pool manager that we want to return the object, and we just give it to him. And he is gonna be responsible to recycle it and just put it away until somebody else needs it. And then we just remove it from our list because we don't need to worry about it anymore. Awesome. Okay, so now what we need to do is let's go ahead and set things up here. The first thing we're going to need is going to be the, let's call it the pool data test. And this pool data test is going to have, actually, let's just delete that and just go ahead and do it to the object sprite. And we're just going to call it test object. Sure. And for the sprite, we're going to use a knob, and we're going to make sure that it is at 0. And maybe 5, not 54, 5. There we go. We just want it like that, and that's good. So let's go back to the project folder, and let's go to prefabs, and let's just drop that in there, and let's get rid of it. And the next object we want is the object pool. So we're going to add that. So this one is the pool data. Now the pool data, you don't add it into the hierarchy. So what we are going to do, we're going to go to resources, and we're going to go into create, and you're going to see this scriptable object, pool data. We're just going to click there, and we're just going to call it pool data test, and we're going to fill it out. So in here, we just want the test object, and 5 is okay. So we're going to go here, and we're going to just set it there. And let's make sure this is at 0. And then we're going to create another one, and we're going to call this one, well, we're going to put the spawner demo there. I'm just going to call it spawner. And we're going to put the object pool there, and we're going to leave that as is. And let's put this as well at 0, 0. So now we are ready to test. Let's go ahead and press play. So if you can see over here on the hierarchy, you can see that, well, let's go ahead and change the, let's change the frequency of the spawn timer to be 0.25 and remove every 1 second right there. Now you should see on the hierarchy that the test object clones are flashing. That means that when they go gray, they're inactive, so they go back to the pool. But when they're dark black, like they are right now, they're being used. And you can see that if, let's say we wanted to speed this up to spawn, you can see that, well, let's do this for now. Let's not spawn any, well actually it's going to spawn really fast, huh? Let's do 100, so let's give them a chance to reset. Well, actually, I think it'll probably work better if we reset it. So, you can see now that with this system, it kind of, it keeps the player or the game limited to a certain amount of objects, which is good for memory. So if you're creating a shooter game, then for your bullets or your enemies, you would want the system to regulate the amount of objects that you are shooting, or the amount of enemies, and the amount of objects that they might be shooting, so that you have better performance in your game.
Congratulations! Now you know what object pooling is, why and how we use it, and how to implement one using Unity and C#. If you would like to follow along, I have provided a link to the project in the description below. And don't forget to also get our free guide where we explain in more detail about what object pooling is in the description below. Also go to our Facebook page. We would love to hear from you. And before you go, check out these other videos on how to make a 2D game using Unity. If you liked this video, hit that like button and be sure to subscribe and share this with your friends. Thank you for watching and see you guys next week. Have a great day and be safe.